3.2 Equations of Lines. So in 3.1, we introduced our concept of a line and how to graph the line. Now we're going to go in the sort of an opposite direction where we're going to focus more on the equation of a line. So we're going to start off with some definitions. First off, the y-intercept. The y-intercept is the point 0, y, where the line crosses the y-axis, while the x-intercept is the point x, 0, where my line crosses the x-axis. The first thing I want to point out about this, let's look at my first definition, the y-intercept. I want to point out that this is a point, 0, y. I want an ordered pair, so the parentheses and my comma are necessary in this case. So whenever I read the y-intercept, I have x is equal to 0, what is y? Whereas for the x-intercept, I'm asking if y is equal to 0, what is x? This is what we're looking at for our intercepts. So, to go ahead and get some practice with the intercepts, let's look at example 1. Given the line y is equal to negative 6x minus 5, determine the x-intercept and the y-intercept. So let's start off with the x-intercept. Remember, the x-intercept is the point x, 0. In other words, I'm asking, what is x when y is equal to 0? Let's look at what happens there. I'll write x-intercept to show that we're working with the x-intercept. So if I look at my equation, y is equal to negative 6x minus 5. Again, I'm asking if y is 0, what is x? So I plugged in 0 for y. Now I must solve for x. If I solve for x, I can do this by adding 5 to the left and the right, giving me 5 is equal to negative 6x. And if I want x by itself, I must divide by negative 6, giving me x is negative 5, 6. So, remember what I said earlier. The x-intercept is a point x, 0. What I have here is not my final answer. For my final answer, I should be putting the point negative 5, 6, because that's my x, comma my y value, which we said is 0 in this case, giving me my first solution. So we have the x-intercept. Now let's look at the y-intercept. The y-intercept is actually just the opposite idea. This is asking what is y when x is 0. So if I look at my original equation again, I'm trying to solve for y. Let me write y-intercept to show we're working with that. What is y when x is 0? So I'm replacing my x with 0. Well, all I have to do here is clean everything up and solve for y. If I clean this up, I get y is equal to negative 6 times 0. I get 0. Minus 5, I just get negative 5. And once again, this is not my final answer for the y-intercept. This is just an equation or a number. I want the point 0, comma, whatever my y value is. In this case, negative 5. So I claim that this is my y-intercept. So we just had an example where we found the x-intercept and the y-intercept. Now that we're a bit familiar with the concept of an intercept, let's introduce another definition. And so, my definition. Every line can be expressed in this thing that we call slope-intercept form, which is given by y is equal to mx plus b. Well, if we look at this, remember from the previous section, we used m to denote the slope. And here we use b to denote the y value of the y-intercept. We call this slope-intercept form because it gives me the slope and the y-intercept, whatever it may be. So this is one of the common ways that we write out lines. So, using our new definition of slope-intercept form, looking at example 2, determine the slope and the y-intercept of this linear equation. Y is equal to negative 2x plus 1. And then I want to graph the equation. Here I have the equation negative 2x plus 1 is equal to y. Well, if I look at this, this looks a lot like slope-intercept form. This looks a lot like mx plus or minus a b. In this case, I'm just asking the slope, what is m? The y-intercept, what is b? So if I compare my slope-intercept form to my equation, I can see that slope m should be negative 2. Furthermore, I can see that I have a y-intercept of parentheses 0, comma, whatever b is, in this case 1. Once again, we really want to make sure that we know that the y-intercept is a point, not just a plain number. So I have the first part of my solution, the slope and the y-intercept. Well, now that I have a point and the slope, I can go ahead and graph my line. Remember, we actually did a similar example in the previous section. So I'm going to start off by graphing my point, 0, comma 1. That's 0 left and right, and 1 unit up. Now, I can use my slope. Remember, slope is rise over run. Or if I want, I can write negative 2 as negative 2 over 1. This tells me if I start at the point 0, comma 1, I can go down 2 units and 1 unit to the right, such as what I have here. And I can continue that process over and over again. Down 2, to the right 1, down 2, to the right 1. Or I can reverse it. I can also go 1 to the left and 2 up. The reason that I'm allowed to do this is that negative 2 over 1, is this not the same as 2 over negative 1? This is still the exact same value. But when I write it in this way, it tells me I'm allowed to go 2 up and left 1 time, repeatedly over and over again. So now if I connect my dots, I should end up with a line that looks roughly like what I have here. So now if I give you an equation in slope-intercept form, we can actually figure out the graph, the slope, and the y-intercept pretty nicely. So let's move to example 3. Find the equation of the line with a slope of 3/5 and a y-intercept of negative 2. Well, let's point out what we have here. I have that I know the slope is 3/5 and my y-intercept is 0, comma, negative 2. If I have the slope and the y-intercept, then I just need slope-intercept form. So once again, I know slope-intercept form is y is equal to mx plus b, where m is the slope and b is the y-coordinate of my y-intercept. Well, if I look at what I've highlighted here, my slope, m, is 3/5. My y-intercept, I have 0, comma b, or in this case, b is equal to negative 2. So all I have to do is fill in m and b. I can write y is equal to my slope times x, and then plus b. Well, in this case, my b is negative 2, so I have plus negative 2, or just minus 2, giving me my final answer. So we're done with example 3. We can actually do this pretty nicely and quickly because we know what the slope is. We know what the intercept is, the y-intercept in particular. So now that we're done with example 3, Just one more practice problem with slope-intercept form. For example 4, write the linear equation negative 2x plus 3y is equal to 6 in slope-intercept form. And then I want you to give me the slope and the y-intercept. So, if I want this equation in slope-intercept form, remember slope-intercept form has y is equal to mx plus b. So if I want to put this in slope-intercept form, in other words, I'm asking, can you solve for y and make it match that mx plus b form? So let's look at this problem. I'm going to go ahead and start by adding 2x to the left and to the right. This way I can write 3y is equal to 2x plus 6. Yeah, I could have put 6 plus 2x, but I'm looking a little bit ahead, and I know eventually I want to get a number times x plus or minus some other number. So I'm going ahead and putting my x first. Again, I want to solve for y. I have 3y, so there's a times 3 in a way. I'm going to go ahead and divide by 3. Doing so, I get y is equal to 2x plus 6 over 3. I want this in slope-intercept form. Again, strictly speaking, a number times x plus a number. Well, right now I don't have that form. It looks more like I have mx plus b divided by 3. So to fix this, I'm going to go ahead and split my fraction up. That is, I'm going to put 3 over each individual term. By doing this, I can write this as y is equal to 2/3 x, a number times x, plus 6 over 3. I can simplify that to be 2. So I just solved for y. And notice, this matches slope-intercept form. This looks like mx plus b. So we're done with the first part of example 4. The second part says find the slope and the y-intercept. Well, remember, the number in front of x, this is mx. So I know that my slope should be 2/3. And my y-intercept, this is 0, comma, whatever my b value is for y equals mx plus b. In this case, my b is positive 2. So my slope m is 2/3. My y-intercept is 0, comma 2. So I have all 3 of my answers. Finishing example 4. Now that we're familiar with slope-intercept form of a line, let's go ahead and introduce another form, that is point-slope form. So if I have the slope and some point, let's call it x1, y1, the point-slope form of a line is given by y minus y1 is equal to slope m times x minus x1. So here we have our point-slope form. Again, remember for slope-intercept form, this gave us the slope and the y-intercept. Well, the point-slope form, this gives us a point and it gives us the slope. So, to really get point-slope form into perspective, let's go ahead and look at example 5. Graph the linear equation y minus 1 is equal to negative 1/4 times x minus 2. So the first thing I'm going to note here is that this looks a lot like point-slope form. I'm going to go ahead and write it right underneath this equation. Point-slope form, we have y minus y1 is the slope x minus x1. One thing to remember about point-slope form is that it's minus y1 and minus x1. It's a common mistake I see each year where people put plus instead of minus. So if I look at and compare this equation to my point-slope form, let's start off with figuring out what my slope is. Well, the slope is what's in front of, in my outside my parentheses, x minus x1. In this case, I can identify my m to be negative 1/4. So let's go ahead and write that down. So I have slope is negative 1/4. And then, since it's in point-slope form, I can also figure out my point, x1, comma y1. Well, in this case, my x1 is just positive 2, and my y1 is positive 1. So this tells me I also have the point, positive 2, comma 1. So now I have a slope and I have a point. Well, if we think back to our other examples, if I have a point and I have a slope, then we can graph our line. And I'll go ahead and highlight my slope and my point to really show that we're using these to graph my line. So starting off, let's graph the point 2, comma 1. That's 2 to the right, 1 unit up. I have 1 point. I know to graph a line, all I need are 2 points. So now I look at my slope. I use the fact that slope is rise over run. Or in this case, I can read it as negative 1/4, or if you want, you can read it as 1 over negative 4. These are all equivalent ways of writing negative 1/4. If I look at the first one, negative 1/4, this means from one point to the other, I go down 1 unit, and then 4 units to the right. So if I have my point 2, comma 1, I'm going to go down 1 unit, and then 4 units to the right, putting me at about right here on my graph. I can also go in the opposite direction. I can go 1 unit up and 4 units left. If I do that from my original point, 1 unit up, 4 to the left, then I'm going to go ahead and end up with, let's see, 1, 2, 3, 4, somewhere along here. Again, all I needed was 2 points, but I like putting a third point to really show that, yeah, I've got the right line in mind. So now I'm going to go ahead and draw a line to connect my dots, extending it all the way across my graph. Now I have the graph of this equation that was in point-slope form. So hence we are done with example 5. Let's move into example 6. Example 6 says, find the equation in point-slope form of a line with a slope of negative 3 and passing through the point negative 2, comma 1. And then I want you to give me the same equation but in slope-intercept form afterwards. So let's focus on the first part. We'll worry about the slope-intercept form after we're done with part 1. So if I read this first sentence, I know for point-slope form, I need a point and I need the slope. So let's see if we can find those. So first off, do I have a point? Well, if I read my sentence, yeah, I've got a point. I've got the point negative 2, comma 1. This is my point. Next, I need a slope. Do I have a slope? Yeah, I have a slope of negative 3. Hence, I have everything I need to write this in point-slope form. So here I have m is negative 3 originally, and my point is negative 2, comma 1. So if I use point-slope form, again, remember this is y minus y1 is equal to m, x minus x1. So if I just fill in the blanks, I have y minus my y value. In this case, my y value is minus 1. Is equal to the slope, negative 3, times, in parentheses, x minus negative 2. Making sure that we're being very careful with our positive and negative signs. All I'm going to do is just clean this up a little bit more by making that minus negative 2 into a plus 2. And hence I have point-slope form. I have y minus y1 is equal to m times, in parentheses, x minus x1. In this case, I have minus negative 2 or just plus 2. Again, make sure that we're doing minus y1 and minus x1. And that's all I want for this example 6 for a point-slope form. Now we can finally move on to the second part, slope-intercept form. So if I want slope-intercept form, remember, once again, This means that I want my equation in y equals mx plus b form. It's still the same equation, just rearranged. So the way I'm going to work with this is that I'm going to look at my point-slope form here. And I know for slope-intercept form, I'm just solving for y. So what I'm going to do is I'm going to clean up this expression. I'm going to write this as y minus 1. I'm going to start off by distributing my negative 3 to both terms, giving me negative 3x minus 6. And now if I want to solve for y, I should just add plus 1 to the left and right, giving me y is equal to negative 3x. Negative 6 plus 1, we get negative 5. And this looks a lot like mx plus b. So hence, I also have this now in slope-intercept form. This is my second answer, intercept form. So this is what I wanted for example 6. Now, to really pack in our point-slope form versus slope-intercept form, let's go ahead and look at number 7. Find the equation in point-slope form of the line passing through the points negative 3, 7, and 1, 1. Let's focus on this first sentence. We'll worry about the rest of this afterwards. So, the first thing I'm noticing is that I want point-slope form, meaning I need a point and I need a slope. Well, I have points. I actually have 2 points. I can use either one if I want. Let's just go ahead and call this one the main point, negative 3, 7. So I have a point, but now how do I get the slope? I don't have something that tells me slope is equal to whatever. But what I do have, I know I can calculate slope if I have 2 points. Remember, slope is y2 minus y1 all over x2 minus x1. Where in this case, I can treat negative 3, 7 as x1, y1, and 1, 1 as x2, y2, for example. Well, if I use these as x1, y1, x2, y2, then I just fill in the blanks. I've got 1 minus 7 all over 1 minus negative 3. Cleaning this up, on the top I got negative 6. On the bottom, 1 minus negative 3. 1 minus negative 3, that becomes 1 plus 3, or simply 4. And since I know that both of these numbers are in fact even, I know for sure I can reduce this down. This is equivalent to negative 3/2. Or if you want, you can put 3 over negative 2. Both of these mean the same thing. So I have the slope. Now that I have a point and I have the slope, I can go ahead and use point-slope form. So my point-slope form, once again, is y minus y1 is mx minus x1. Well, if I identified this point, negative 3, 7, to be my point of choice for x1, y1, and this to be my slope, then I just plug in the blanks. I get y minus 7 is equal to negative 3/2, or 3 over negative 2, whatever you prefer, times x minus negative 3. Well, minus negative 3, that becomes a plus 3. Hence, I have my equation in point-slope form. One thing I want to point out is, here I chose negative 3, 7, but you could have also used the point 1, 1. Maybe you used y minus 1 is negative 3/2 x minus 1. That would be a legitimate answer as well. My choice of point doesn't really matter as long as I choose a point that was given for us. So we're done with the first problem. Now, I want the same equation in slope-intercept form. Recall what we did in the previous example. All I did was take my equation that I had earlier, and then I cleaned it up and solved for y. So if I clean this up, I get y minus 7 is equal to, after distributing negative 3 halves, I get negative 3 half x minus 3 halves times 3, that becomes 9 over 2. Now, all I have to do is add 7 to the left and to the right. If I add 7 to the left and the right, I get y is equal to negative 3 half x. That hasn't changed. And then negative 9 over 2 plus 7. You can either calculate this in your calculator, or if you want to do it by hand, I'm going to do it right here by hand as well. Negative 9 over 2 plus 7. Remember to add two numbers where I have a fraction. I have to have a common denominator. So between the denominator of 1 and 2, I have to multiply my second term by 2 over 2. Or in other words, negative 9 over 2 plus 14 over 2, which will give me positive 5 over 2. Now I have something that looks like y is equal to mx plus b. So hence I have the same equation. Both of these equations give me the same type of information. They graph the same line, but they're just in a different format. They're in a different form. Thus, we are done with example 7. Now, with example 7 being done, we're familiar with point-slope form, slope-intercept form. There's one more thing I want to talk about for lines, and a couple of examples. So, I want to talk about the idea of being parallel or perpendicular lines. So we have a definition. If I have two lines, and the lines never cross each other, they never intersect, they never touch, then we say that the lines are parallel to each other. And in fact, two lines are parallel if and only if they have the same slope. So here I have a picture where I have two lines, and then their slopes are equal. Or I might have where their slopes are equal by the fact that they're both undefined. So we have parallel. And then my second definition is perpendicular. If two lines, whenever they cross each other, form a right angle, then we say that the lines are perpendicular. So here I have this picture, two lines crossing, and you can imagine, since they cross, it looks like they form a perfect 90-degree right angle. As it turns out, two lines are perpendicular if their slopes are negative reciprocals of each other. What does that even mean? That means if I have one slope, the slope of the perpendicular line will be the negation and flipped over. For example, if one of my slopes is, negative 2, then the perpendicular line would have a slope of 1 over 2. We can see that one's positive, one is negative, and then they're just reciprocals of each other. That means I can flip them and I get the other result. So if you flip 2, you get 1/2. If you flip 1/2, you get 2. And then here I just have another picture where if I have the slope of 1 is 0, then the perpendicular line must have a slope that is undefined. This is still a right angle as well. So we have the definition of parallel and perpendicular. Let's go ahead and apply it. With example 8, determine if these two lines that I've given you, tell me, are they parallel, are they perpendicular, or are they just two random lines without any really great relationship? So I have two equations, negative 4/3 x plus y is equal to 5, and negative 4x plus y is equal to 7. Remember, in order to figure out if two lines are parallel or perpendicular, or neither, I need to know what their slope is. Well, if I look at these two equations, I can't automatically tell what the slope is. However, I do know that if my equation is in slope-intercept form, or point slope form, then I know what the slope is. For this one, let's go ahead and see if I can put both of my equations in slope-intercept form. That is, can I make the left equation and the right equation both look like y is equal to mx plus b? Starting with the left one, I can just go ahead and add 4/3 x to the left and to the right. If I do that, I'm left with y is equal to 4/3 x plus 5. And conveniently, this is already in slope-intercept form. I have mx plus b. So for this one, I note that my slope, I'm going to call it m1 to say slope of the first line, is 4/3. Now I'm going to continue on with the second line. I'm pretty much going to do the same thing. If I add 4x to the left and right, I have y is equal to 4x plus 7. This looks like mx plus b. So what's my slope for the second line? The slope of my second line, I'm just calling it m2 to just say another line. The slope here is 4, the number in front of x. So now I'm comparing my slope over here and my slope over here. So if they're parallel lines, the slope should be the same. Well, if I look at these two slopes, obviously I don't have the same slope. So I know I'm not parallel. So parallel is already out of the question. What about perpendicular? Well, perpendicular means that from one slope to another, I have the negative reciprocal. Well, just looking at this already, it doesn't even fulfill the condition that one is the opposite sign. Here I have positive 4/3 and positive 4. So I don't even have a negation. So I automatically know I'm not perpendicular. You could also say that if I do the reciprocal of 4/3, you would get 3/4, which is obviously not even 4. So that's another way that we can say that we're not perpendicular. So I'm not parallel, I'm not perpendicular, I must be neither as my final answer. Neither parallel nor perpendicular. So if I give you the equation of any two lines, you should be able to tell me if it's parallel, perpendicular, or neither. This is what I want from example 8. Moving on to the example 9, find the equation of the line that's parallel to this line and passing through the point 1, -2. So if I want the equation of a line, again, I need two things. I need a slope and I need a point. Those are the two things I need. Well, I have a point. I have 1, -2. So that condition is already done. But what about the slope? How can I get the slope of the line? Well, now I have to use this other condition, parallel to this line. Well, if I want my new line to be parallel to my old line, then the slope has to be equal. So my job is looking at this equation and figuring out what is my slope. So there's a couple of different ways that we can do this. One way we might do this is I can recognize that this looks a lot like y minus y1, m x minus x1, where m is the slope. If I compare these two forms, it turns out my equation here is exactly in point slope form. That is, my slope of this line, let's call it m1, is 2. So, since I know the slope of my old line is 2, and I want my new line to be parallel, that means I should use a slope of 2 as well. I'm going to highlight that to show that it's important. So I have a slope and I have a point. Now I just use point-slope form. And actually I already have it written up here. We have y minus my y1 value, in this case minus -2, is equal to my slope 2x minus x1, or in this case minus 1. Now I could leave it in this form for a point-slope form. Maybe I want to change this minus, that should not be a 3. Write this to be plus 2 is equal to 2x minus 1. If I leave it in this form, remember this is our point-slope form, like so. This is one acceptable answer, depending on what I'm asking for. Here I was a little broad, and then I just said find the equation. So you should make sure that you know how to write it in point-slope form or the slope-intercept form. If I want this in slope-intercept form, we know how to go from point-slope form to slope-intercept form. In other words, for slope-intercept form, I need to solve for y. Like so. So if I want to solve for y, I would start off by distributing my 2, giving me 2x minus 2, and then subtracting 2 to get y by itself, granting me y is equal to 2x minus 4. This is also an acceptable answer. It depends heavily on, am I asking for your final answer in point-slope form or slope-intercept form? So we have example 9. We are finally at our final example for this video. Example 10. Find the equation of the line perpendicular to negative 2x plus y equal to 3 and passing through the point 3, 1. First thing I'm noticing is that I want the equation of a line, which we know we need a slope and we need a point. Well, if I read the sentence, I have a point, 3, 1. I'll go ahead and write it next to here. I need a slope. To figure out my slope, I look at the rest of this statement. I want it to be perpendicular to negative 2x plus y is equal to 3. I know to be perpendicular, I need to figure out the slope of this line, negative 2x plus y is equal to 3, and then I need to take the negative reciprocal. So, looking at this equation, I can't use my point-slope form, but I can rewrite this to be in slope-intercept form. What happens whenever I add 2x to the left and to the right? I'm simply left with y is equal to 2x plus 3. Again, that's because I added the 2x from the left to the right. This looks like y is equal to mx plus b. If I do a comparison, I can say the slope of my original line, again, I'm going to use m1 to say for the original line, is positive 2. Since I want a perpendicular line, that means I need to take the reciprocal of 2. If I flip 2, I get 1/2. Because remember, 2 is the same thing as 2 over 1. And then I need to take the negation. My original slope was positive 2, so my new slope should be negative 1/2. So I have my slope and my point. Now, since I didn't specify the equation form, we're going to go ahead and write our equation in point-slope form and then slope-intercept form. For point-slope form, once again, we have y minus y1, or in this case, y minus 1, is equal to my slope, m x minus x1. Again, this is my slope-intercept form. If I want this in slope-intercept form, I can't remember if I said earlier by accident slope-intercept form. What I highlighted here was point-slope form, and we're going to work with slope-intercept form. Excuse me if I did say that wrong. So this is our point slope form. I'm going to write it as PS form. And I want my slope intercept form. So we know to go from point slope form to slope intercept form, I just have to solve for y. We do that by, I like distributing my slope and multiplying it. That is, if I take 1/2, negative 1/2, and multiply it across, I get negative 1/2 x plus, because a negative times a negative, 1/2 times 3, I get 3/2. Now I just add 1 to the left and right, and I'm left with y is equal to negative 1/2 x, and then 3/2 plus 1. You can either do this in your calculator, or if you want to do this by hand, 3/2 plus 1, this is a side note. This is the same thing as 3/2 plus 2/2, which gives me 5/2. So I have negative 1/2 x plus 1/2. This is our slope intercept form. So I have the equation of a line perpendicular to my original line. Again, to get the equation of a line, I need slope and I need a point. I already had my point. For the slope, I had to use my old equation and then use that slope, depending on if it was parallel or perpendicular. So hence, we are done with example 10 and done with section 3.2.